Assalamualaikum and hi everyone. We are from Group 5. I am Muhammad Fahmi AFHAM. My member is FAHAN ARIFF, AMIRUL Abu Bakar and DIVASAN. We will discuss the second theory assessment. I will now share my screen. I will explain about the question A1, which is describe the following laws with the aid of circuit diagram. Number one is Kirchhoff's voltage law. So what is Kirchhoff's voltage law? It means that the algebraic sum of all potential difference around any closed loop in the network is equal to 0 at all times. So I will now draw the diagram. Okay, as you can see, this is the circuit diagram. For Kirchhoff's law, we firstly decide the loop either the clockwise or counterclockwise. This is the loop. Sorry, it's ugly. Okay. So when the voltage source plus voltage 1 plus voltage 2 plus voltage 3 and voltage 4 it must equal to 0. So that we just follow the loop, the direction of the loop, the negative, because the current is entering the negative at the voltage source, so we make it negative voltage source plus voltage 1 plus voltage 2 plus voltage 3 plus voltage 4, and it must equal to 0. So the most simple equation for this Kirchhoff voltage law is sigma V is equal to 0. I will write the answer in Notepad and then post it here. I think that's all for question A1. I will move on to question A2. For the Kirchhoff current law, the algebraic sum of current entering the node is 0 at all instant of time. So I will first draw the diagram. So as you can see, this is current entering and leaving the node A. This is node A. So for the Kirchhoff law, at the node in the network, the sum of all current flowing into the node I1 and the sum must equal to the sum of current entering leaving out the node I2 plus I3. So we can make the equation as I1 for the current entering the node, the sign is positive, but for the current leaving the node, the sign is negative. So I1 minus I2 because the I2 is leaving the node, and minus I3 because I3 is also leaving the node must equal to 0. So we can also get the I1 by just simply switching the the I2 and I3 to the right side of the equation. I1 is equal to I2 plus I3. Okay, everyone, you get the answer?
Yes.
Okay, so I will put my answer into the Jamboard. I think that's all from me. We will now move on to the question B1. Can Amirul present it?
Okay, so my name is AMIRUL, and I'm going to present the question B1. So, B1, it requires us to determine what is I1, B1, and B2. So, to find I1, we have to look at this node right here. Okay, can you see it?
Yeah.
I circle it. All right. Okay, so this node, I will draw it here. All right. So, there are three different currents going in and out of this node. Here we have I1. Over here we have I2. And what's coming out of this node is I3. So if we look at this node, we can conclude that I1 plus I2 is equal to minus I3, because I3 is coming out of this node, so it's minus. And based on Kirchhoff current law, the sum of a current entering a node is always equal to 0. So from this equation, we can get I1 is equal to I2. We already got 3 ampere, and I3 we got this 5 ampere given from the question, equal 0. Okay, let me put it right here. So based on this, we can get I1 is equal to negative 3 plus 5. So we get I1 is equal to 2 ampere. Okay, so that is it for I1. And to get V1, we have to look at this loop right here. Okay, as you can see here, this loop. As FAHMI said earlier, the sum of all voltage in a closed loop is always equal to 0. So we can get V1 plus VB plus V3 plus VD equals 0. So the all the other voltages are given. So just substitute them into VB, VC, and VB, and we get 1 plus 11 volt equals 0. So just move this 11 volt to the right side, and we get V1 equals negative 11 volt. Alright, so that is for V1. I will write the answer right here. Moving on to how to get V2 is we have to look at this loop. Wait, at this loop here. Okay. So the current goes in from here and then here, meaning positive VE, meaning positive V2 minus VC. So we get V2, V2 minus VC equals 0. We already know VC is 6 volt, so V2 minus 6 volt equals 0. And then we can get V2 is equal to 6 volt. Okay, so that is the answer for V2. So, alright, so we're done with number B1, and then we move on to B2.
Okay, I think
You're already done?
I think that's all from Amirul. So we will move on to the question B2. Please
Okay,
discuss
me too.
about it, Divasan. Okay.
Yes. Hi, my name is DIVASAN. And now I want to explain about the B2. The first B2 request about the compute the power of each element A, B, C, D and show that power is conserved. Example like the algebra sum of the power is 0. First, we have to compute each element which is A, B, C, D and E. Okay. First, the power of formula is P equals to voltage times current. Okay. Now we have to calculate the power of A. I write in the text first. Now you guys can see.
Yes, you can see.
Yes, can.
Yes. Now the formula of the power PA equals to voltage and current times current. So we have to times voltage 1 to current 3. So that is the value of voltage 1 is negative 11 and the current of 3 is 5. So we can calculate and we get negative 55 watt which is supplying. Now we have to calculate the B. And now we can see for the PB the current of power of B. V, the voltage B and current 3 is the 3 times 5. Now, so we calculate, we can get the 15 watt, which show that absorbing. Now we have to calculate the power of C. Okay, now you guys can see for the power of C. For the voltage of C is 6 and the current of 1 is 2. So we calculate get 12 watt. So it's show which is absorbing. Now we calculate for the D. Now you can see for the power of D, which is the voltage D is 2 and the current 3 is 5. So we calculate, we can get the 10 watt, which is absorbing. Now we calculate for the E, power of E. And now we can see for the power of E, which is voltage 2 is 6 and the current 2 is 3. So we calculate that we get 18 watt, which is absorbing. Okay, now lastly we have to do what? We have to plus each of the element. So we know what we get. First, I done that first. I will explain. Okay, now you guys can see we calculate plus the all of the element, which is for the power of A negative 55, power of B 15 watt, power of C 12 watt, and power of D 10 watt, and power of E 18 watt. Okay, now we have calculated that is so negative 55 plus 55 equals to 0. For the negative 55 is power supply, that we know the positive 55 is power that absorbed. Okay, this is the consider of the power is conserved. Okay, that's all guys.
Okay, thank you, Divasan. We now move on to the question C. Fahan, can you explain about the question C?
Okay. Let's look at the question first. Okay, the question asks us to determine the I, V1, and VAB. Okay, first, let's look at the diagram. It's given. To determine the I, we must have the R equivalent. So, the R equivalent. So let's start with the R equivalent. First one is this resistor, 2 ohms, plus this one, these two resistor is in series, so we combine it. The 4 plus 2 is 6, and then we look at the 6 one and this resistor. It's parallel, so we use this formula, 6 times 3 over 6 plus 3. Okay, then we have the last resistor, which is this resistor, plus 2. So we total up and we get a R equivalent is 6 ohms. Okay, so we have the information, so we can calculate the I. So I is V over R equivalent. So V is given 12 volt over R equivalent, which we calculate, which is 6. And then we got I is equal to 2 ampere. Okay, that's for the first one. Wait a minute.
Fine.
Yeah.
No need to erase the answer. Just do it in the next slide.
Next page.
Okay. Then I will put the question into the next slide.
Okay. Okay, for the next question, we're looking for V1. So to calculate V1, you must have the current here, which is IA. So to calculate IA, we use the current division technique. So let's do it. IA is equal to this branch we have this is parallel. So we use 3 over this is 2 series resistors, so we total up, so we get 6 plus this resistor 3 times the I total, which is 2 ampere. So we got IA is 0.6667 ampere. Okay. So we got the IA, so we can calculate the V1 using the formula V1 is equal to IA R for ohms. So we use the information we got 0.6667 times 4 ohms. So we got I1 is 2.6668 volt. Okay, that's for V1. The next we move to the VAB. Okay, let's look at the question. VAB, which is V at this terminal to this terminal only. So this resistor is not included. So we look at it at these branches only. Okay, first we find the R equivalent for terminal A to terminal B. RAB is equal to 6 plus 3 over, oh, sorry. It's not 6 plus 3. It's 6 times 3 over 6 plus 3 plus this resistor 2. So we got RAB is equal to 4 ohms. So to calculate VAB, we use the formula VAB is equal to I RAB. So we substitute. We got I, which is 2 ampere, and RAB is 4. And then calculate, we got VAB is equal to 8 volt. Okay, I think that is all for me. Thank you.
Okay. I thank you everyone for explaining the question question A until C. I think that's all from group 5. Thank you for watching.
Thank you, guys.
Thank you.